Okay, as you can see in this part of indefinite integration or antiderivatives, we're going to talk about rules of integration, a real quick review, a review of the special integrals we have, then some warnings of rules that we don't have, don't make something up, basically, and then a few more examples that puts everything together, I hope. So rule number one, let's recall, says that if we have the integral of a constant, so k just represents a constant, with respect to x, then the result we get is that constant times x plus the constant of integration that we always get when we do an indefinite integral. Okay, now, just as a reminder, it depends on the variable what answer we get. In other words, if we had an integral of a constant with respect to t instead of x, then the variable is t. So our answer would be that constant times the variable t plus a constant of integration. Okay, our second rule, as you recall, is what we call the power rule. And the power rule says that if we have the integral of x to a power with respect to x, then we can, what we end up doing, or what we do, is we add 1 to the power, so now it's n plus 1 as a power, and in front of that we put the reciprocal of that new power as a factor. So we put the fraction that's the reciprocal of the power. So if the power is a fraction itself, then the reciprocal, of course, we would flip it. If the power is an integer, like 2, well, then what we'd have in front would be a 1/2, wouldn't it? Okay, and don't forget our constant of integration. And remember, this rule works provided n is not -1. And we have a special integral when for the case n is -1, don't we? Now, again, we need to remember that this is assuming that we're talking about x as a variable. But we could do the same thing. We could say, suppose we have the integral of u to the n power with respect to u. See, this is indicating that u is the variable. And so then the answer in this case would look like 1 over n plus 1 times u to the power n plus 1 plus our constant of integration. Just keep in mind that we can have different variables. Okay, the third rule was what would happen if we have the integral of a constant times a function. And we haven't seen that used a lot. I mean, we've seen a constant times e to the x, or a constant times the natural log of x, or a constant times x to the 4th power, for instance. And so each of those cases, we're thinking of the x to the 4th, or the natural log. I mean, no, we haven't had natural log, I'm sorry. Or e to the x. In those cases, then we're thinking of the e to the x, or the x to the 4th as the function. And what this says is that we can factor out that constant, that we can put the constant in front of the integral, okay? And then we just have to worry about finding the integral of the function. Now, it's very important to recognize that this k is a constant. It's not a variable. See, it doesn't say that we can do that with a variable, and that is actually one of the warnings that we need to be careful of. So it doesn't work taking a variable outside the integral. It only works taking a constant outside the integral. Okay, then the fourth rule that we had, that we talked about, was what happens if we have the integral of things added or subtracted. Now, the rule showed just adding or subtracting 2 things, but in practice we saw we could add and subtract 3 or 4 or 5 or any number of things. And it's a simple idea. The integral of things added is the addition of integrals. That is, we take the integral of the first one. Whoops. Tried to be real neat, and I wasn't. We take the integral of the first part, and then we add or subtract appropriately the integral of the second part. And if we had more parts, we would add and subtract appropriately the additional parts. So those are the 4 rules that we have. And then we had 2 special integrals, okay? Not we had, we have. two special integrals. And those special integrals are, one, the integral of e to the x with respect to x, or it could be the integral of e to the t with respect to t, or so on. But that is just e to the x plus a constant integration, because the derivative of e to the x is e to the x. Okay, and then the second one was to kind of fill in for rule number 2 up there. That is, if we have the integral of x to the negative 1 power with respect to x, and a lot of times we won't see it that way. We'll actually be given the problem, remember, the integral of 1 over x with respect to x. Well, that's special. The power rule won't work here. That number 2 rule up above won't work. What we have to remember is that when we have this, it's the natural log of the absolute value of x, and we do need that absolute value there, so be careful to remember that all the time. So there's a summary of what we've been doing in part 1 and part 2. Now, on the next page, I want to give you some warnings about things that I haven't talked about, and I haven't talked about them because we can't do them. So let me remind you of that, or do that on the next page. What I'm going to do, I said I was going to show you some warnings on this page, but I think what I'm going to do is mix in examples and show you things that we can't do that we might be tempted to do, and give a warning at that time. So here's the example that we're going to start with. We're asked to find the integral of, let's see, how about 3x squared times x to the 4th plus 2 with respect to x. So that's the integral we're supposed to find. Now, here's the first warning. We might be tempted, we might be tempted to try to decide that, well, why don't we find, let me tell you the warning first. There is no product rule. Okay, there is no product rule for integrals. Now, for derivatives, there is, but not for integrals. There's no product rule for integrals. And so what that means, there's something that we can't do here. That is, it would be tempting to say, when we're faced with a problem that looks like this, why don't we, that's an exponent of 4, why don't we just take the integral of the first part, why don't we take the integral of 3x squared with respect to x, and then multiply that with the integral of x to the 4th plus 2 with respect to x. That'd make easy work of that, wouldn't it? But we can't do that. We don't have a product rule. So this is out. This is no way. Can't do that. We can do the problem that we're asked to do, and the way we would do it, okay, this is okay. What we're going to do next is we're going to take this integral, and we're going to look at the integrand. That's what we're taking the integral of. And we notice that inside the integral, it's all right to multiply, because that's what it actually says that we're doing, doesn't it? So we would take that 3x squared and multiply it with the x to the 4th, so we'd have a 3x to the 6th power, wouldn't we? 4 plus 2. And then we'd take that 3x squared and we'd multiply with the 2, and that would give us a 6x squared. Okay, now that's just a polynomial we can find the integral of. And so we would look at taking the integral of the first term, so we have that 3 that's in front of the x to the 6th, and when we integrate x to the 6th, we would increase the exponent by 1, and then in front of that x to the 7th, we would put a factor that's the reciprocal of that new exponent. Then plus, now we're taking the integral of 6x squared, so we're going to have a 6, and then when we take the integral of x squared, we increase the power by 1, and then we have to put a factor that's the reciprocal of that new power. The reciprocal of 3, of course, is 1/3. And then we have plus, don't forget, It's easy to forget. Don't forget our constant of integration. And now we would just go through here and we would clean up. That is, we would say 3 times 1/7 is 3/7, and times x to the 7th power. And then 6 times 1/3 happens, 6 over 3 happens to be 2, doesn't it? So that simplifies to 2 times x to the 3rd power plus our constant of integration. So we could do it this way, but we can't multiply integrals together. So we can't just take the integral of each part. Be careful of that. That's the first warning. Now, the second example that I want to do here, okay, we're asked to find an integral, of course, and we're asked to find the integral of, let's see what I've got prepared. Okay, we want to find the integral of a fraction, x cubed minus 3 divided by x to the 2nd power. And we're finding the integral with respect to x. Well, here's the next warning, and it's another important warning. There is no quotient rule. Not only have we not talked about it, see, we didn't talk about a product rule for integrals because one doesn't exist. And there is no quotient rule. Of course, the quotient rule for integrals, the quotient rule for derivatives is very complicated, isn't it? And even the product rule is. And so you might think that there's a complicated product rule for integrals. You might think there's a complicated quotient rule for integrals. But there is none. See, there is no quotient rule. So what that kind of tells us, maybe it doesn't tell us this, but it is this is a true statement of something we can't do. When we have the integral of a fraction, what we cannot do, okay, what's not allowed is to change that and say, oh, well, let's find the integral of the top and divide by the integral of the bottom. Whether you write it out or not, you can't find the integral of a fraction. Okay, that's not allowed. You can't find the integral of a fraction by taking the integral of the numerator and the integral of the denominator. So in other words, you're not allowed to do this. Don't ever do it. Don't make up that rule because it's not okay. Now that doesn't mean we can't find the integral that we're being asked to find here. We have to do a little work before we can do the integral. That is, we have to write it in a form that allows us to do the work. So let me start over here and we'll work on this integral. We're finding the integral of the fraction x cubed minus 3 over x squared with respect to x. Well, we're used to the idea that we're having to use algebra a lot of times to get started. And so what we're going to do is we're going to take this fraction, x cubed minus 3 over x squared, and break it into two fractions, x cubed over x squared minus 3 over x squared. So we're making it into two fractions. Obviously, I hope you understand that those are the same. We're really having to divide x squared into both parts. Now, in the first fraction we have there, x cubed over x squared, that's just simply x, isn't it? That simplifies to x. And in the second fraction, we notice, and this is kind of a reminder, I'll write it over here on the side, you know, if I had 3 times x to the negative 2 power, that would mean that's 3 times 1 over x squared, which is 3 over x squared, isn't it? So I'm really needing you to think backwards here. 3 over x squared is really 3 times x to the power negative 2. Now, I have a polynomial of sorts. Although I've got a negative exponent, I just have terms that involve powers of x. And so I ought to be able to integrate that. So we start out, although we could break it into two integrals, we've kind of seen how we'll just think about the integral of x, and then we'll think about the integral of 3 times x to the negative 2 power. Well, remember the integral of x, what do? We remember x has a power of 1, so when we increase that power by 1, we get a power of 2. And then we have to put a reciprocal factor in front of that, so it's a 1/2 in front of that. Then we have our minus sign, and then we have that factor 3, and we're going to integrate x to the negative 2. Now, as soon as we get exponents that are negative, I kind of come over here to the side until I'm used to it. I'm going to take the old exponent, which is negative 2, and add 1 to it. And that's going to actually give me a negative 1 exponent, isn't it? So my exponent here is negative 1, and so what I have to put as a factor in front is 1 over that negative 1. Of course, 1 over negative 1, well, we'll come to that in a moment. Don't forget our constant of integration. Now, the next thing, obviously, to realize is that 1 over negative 1 is just negative 1, isn't it? And so what we have here is a 1/2 times x squared in front. And then we have a negative 3, and then times a negative 1, and then times an x to the negative 1. Well, that negative 3 times negative 1 makes that a plus 3, doesn't it? And x to the negative 1 power is really, well, let's write this. X to the negative 1 plus our constant of integration. And since I'm at the bottom of the page, I'm going to come over here horizontally, which normally I would not do. But the only other thing I'm going to do is I'm going to rewrite 3 times x to the negative 1 as 3 times 1 over x. And so it's going to end up looking like 1/2 x squared plus 3 over x. 3 times x to the negative 1 is 3 over x, isn't it? Plus our constant of integration. Now, again, let's make sure that we understand. I'm kind of over here in the sideline here. 3 times x to the negative 1 means 3 times 1 over x. And that's how I got 3 over x. So let's keep that in mind. So anyway, there is the second warning, of course, is that we don't have a quotient rule for integrals. And so one thing that means is we can't take an integral of a fraction by taking the integral of the top and the integral of the bottom. We have to manipulate the fraction so that we have powers of x. As we continue our examples, you see that we're asked to find the integral of 5 times the cube root of u squared with respect to u. As we begin that, let me, just normal, it's kind of like I'm reading it out of the book. I'm going to start my problem by rewriting the integral so that I can begin down here. So the integral of 5 times the cube root of u squared with respect to u. So the du is telling me that the u I see in my integration is actually the variable, not x. Now, because we have this constant 5, we've seen that before we can factor out that 5, can't we? We can factor that 5 out, write it outside the integral sign, and so then we're just worried about the integral of the cube root of u squared. Now, what I need you to remember, and you're going to be faced with this a lot of times, is that what we're really dealing with so far is mainly powers of x, or powers of variables. In this case, we need to deal with powers of u's. And so whenever we see radicals, we want to turn around and rewrite them before we integrate as a power. And so remember, if we have a cube root of u squared, that really means u to a power of 2/3. See, the 3 in that exponent means the cube root, and the 2 in that exponent means a regular squaring. And so now we know how to integrate something that looks like a power, or is a power. So what we have to do is remember that to integrate u to the 2/3 power, formally what we're doing is we're going to increase that power by 1, and then in front of that we have to reciprocate. That is, that we have to multiply, by 1, the new exponent, the reciprocal of the new exponent. Now that's really messy. You know, that's what we're doing, but that's not the way I would actually approach it. So what I would do is I'd say, okay, I know I'm going to increase the power 2/3 by 1, so let me figure out what 2/3 plus 1 is. And of course, since I'm adding 1, 1's easy to change to 3/3, isn't it? And so I see, of course, that new power I'm going to have is 5/3. And so I write the 5 down. Again, this is formally what we're doing, but I'm going to do it the way I would really do it. Okay, so I found out the new power that I need is 5/3 because that's 2/3 plus 1. And so then I remember in front of this, then I have to write down the reciprocal of 5/3. And instead of saying 1/5, we just know the reciprocal of 5/3 is 3/5, don't we? So that's the reciprocal of the new exponent, and then we say, don't forget our constant of integration. And then we would simply clean this up. 5 times 5/3 is 3, and so we'd have 3 times u to the power of 5/3 plus our constant of integration. Now, it is true that we can rewrite that in a different way. See, we didn't have u to the power to begin with, and so there's probably nothing wrong with this answer, but let me just kind of remind you, I'm going to write sideways here, that u to the 5/3 power means the cube root of u to the 5th. But whenever we have a power under a radical that's bigger than the index, we ought to be able to simplify that. See, this is really the cube root of u cubed times u squared. U to the 5th is u cubed times u squared, isn't it? And the cube root of u cubed, remember, is just u, and so we have u times the cube root of u squared. So an alternative way to write this answer, although it's not going to be necessary here, is we could say that this is 3 times u times 3u times the cube root of u squared. I'll spit it out here in a moment. Because we simplified u to the 5/3 power as u times the cube root of u squared. So that's an alternative way to write it. Okay, let's look at the next example that's going to look very similar to this, but it's going to be different. And it's important to recognize the difference. So here, we're asked to find the integral of x, excuse me, not x, u times the integral, well, I'm so sorry, I really am. Let's do it in terms of x. Let's say the integral of x times the cube root of x squared with respect to x. Okay, now, of course, the difference here, there's two differences. The difference first is the variable is x. That's not that big a deal. And the second difference is the multiplier in front of the cube root is x this time instead of 5. And the significance there is the multiplier is a variable. So here's the warning. Okay, big warning. You can take a constant factor out of the integral, outside the integral, but you cannot take a variable outside the integral. Which means in this case, just kind of an idea here, that that the integral of x times the cube root of x squared with respect to x, we can't say take the x out and then just find the integral of the cube root of x squared, like we did above where we took the 5 out. And the reason we can't do that is because x is a variable, and so we can't remove it from the integration. And we also saw on the previous page that we can't take the integral of x and the integral of the cube root separately, can we? See, that we don't have a way to take the integral of things multiplied together. So we have to have another method of doing this. And that's not really that bad. We just have to be a bit creative. So here's the integral that we're working on, the integral of x times the cube root of x squared with respect to x. Now, what we have done in the past is that we've written that cube root, and we saw it above. Cube root of x squared is nothing more than the power 2/3, right? The cube root of x squared is the same as x to the power 2/3. So as soon as we write that cube root in that way, we recognize that we just have, we really just have x to the first times x to the 2/3 power. And so that would be x to a power. We would add those two exponents, wouldn't we? See, and 1 plus 2/3 ends up being 5/3, doesn't it? So what we're really doing is finding the integral of x to the 5/3 power here. See, it just didn't look that way, but that's what we're doing. Okay, well, to do that, what do we do? How do we handle that? Well, what we do is we increase the power by 1. Okay, now this is separate. Let's do something else. So we take that 5/3 power and increase it by 1. Well, 5/3 plus 3/3 is 8/3, isn't it? So that would end up being x to the 8/3 power. But remember, in front, we have to have the reciprocal of that new power. And so that would be 3/8. And then plus our constant of integration. Now, it's probably going to be okay to leave this answer. We've done the job. The thing that we might end up doing and finding out later is that we could simplify it. And I'm just going to write the simplified form over here. That is, we could write x to the 8/3 power actually as the cube root of x to the 8th. And if we did that and simplify, that would be x squared times the cube root of x squared. That's what we would end up with, plus our constant of integration. That's if we were to write it back in terms of a radical. But what we've got here is just fine. And again, the warning is, 2 warnings all at once here. We can't take a variable outside the integral, and we can't integrate a product by integrating each factor in the product. We have to deal with some other method. So our last warning, before we do the last warning, I want to remind you of a couple of things real quickly. And one of them is that we have this rule for integrating powers of x, that is, the integral of x to the power n with respect to x. We add 1 to the exponent, don't we? So we have an n plus 1 now exponent, and then of course in front we have the reciprocal of that new exponent plus our constant integration. That's as long as n's not -1. So for instance, here we would end up, as an example, just as a reminder, which you know very well by now, the integral of x to the 5th will be 1/6 times x to the 6th power, plus our constant integration. We added 1 to the exponent 5. Now, compare that to what we learned about finding the integral of e to the x. The integral of e to the x with respect to x is just e to the x plus a constant integration. And see what it is not equal to. See, it's not e to the x plus 1 power, is it? See, we didn't add 1 to that exponent, did we? And of course, we don't have a 1/x plus 1 out here either. See, it's not that. We don't deal with it like we do with a power rule. And kind of the big thing to remember here is that the power rule up here only works when the power is a number, a constant, see? If the power is a variable, as it is here, then it has to be completely different. And so I'm not giving the whole story, but I don't want you to start adding 1 to an exponent of x. I don't want you to start that. I know that you haven't yet, but don't do that in the future either. Okay, let's. I'd like to end with 3 more examples, and this is just mixing things up. That is, I think 3 more examples. As I've said, I know this is long. There's each of these parts is long, but it's very important to get off onto a good foot here so that you don't have trouble later on. So this example, we're to find the integral of 5 over x minus 4 times e to the power x with respect to x. I'm going to be a little more formal on this example. As I'm beginning to do the problem, I'm going to rewrite it here. The integral of 5 over x minus 4 e to the x power. Okay, that's what we're doing. Now, I say I'm going to be a little more formal here. I'm going to formally break this into 2 integrals because I can't think about either one of these easily in my head. And so I'm going to write this as the integral of the first part, 5 over x with respect to x, and then subtract the integral of the second part, and that's 4 e to the x with respect to x. And so now I just have to think about 2 integrals. And of course, the secret in this first integral is to really recognize that 5 over x is 5 times 1 over x. Or we can say it's 5 times x to the negative 1. Okay, and the reason I say that's the secret there is because we have to recognize that when we integrate 1 over x, we integrate in a special way. But in each of these pieces, I see that I have a constant factor now. See, that 5 is a constant factor, not a variable factor, so I can factor it out. And in the second integral, that 4 is the constant factor, so I can factor it out. When I say factor out, I mean take outside the integral sign. And then, of course, now I'm needing to remember that the integral of 1 over x is the natural log of the absolute value of x. And then I need to remember in the second integral that the integral of e to the x is just e to the x. So I've written my 4 down, and now the integral of e to the x is just e to the x, and then plus our constant of integration. So I broke it down to thinking about 2 simple integrals, and that's how I was able to get the 2 results that I got. Okay, on the next page we'll do the last 2 examples. So let me pause to get set up for that. Okay, you see we're asked to evaluate the integral or find the integral of x squared minus 2 times the quantity x plus 3 with respect to x. So this is how we get caught so many times, because we look at that and we can say, oh, I can integrate x squared minus 2 real easily, and I can integrate x plus 3 real easily. And so, you know, it's back to the warning. We can't, see, we can't do the integral of each part. This is not allowed. I can write it all out, but I'm thinking, you know, you might be thinking, oh, the integral of x squared is 1/3 x cubed. And the integral of 2 is just 2x. And then we'd have the integral of x, which is just 1/2 x squared, and the integral of 3, which is just 3x. See, that unfortunately, that's not something we can do. We can't take the integral of 2 things and then multiply those together. So again, this is not allowed. That's a big fat X. We can't do it that way. We have to be very, very careful of things like that, not be caught in that trap. Here's the way we do this problem. We're asked to find the integral of x squared minus 2 times x plus 3. And remember, we are worried about things that are multiplied together, how we deal with those. And so what I'm going to do is I'm going to come over here to the side, and I'm actually going to find out what x squared minus 2 times x plus 3 is. I'm actually going to do that multiplication. I just use FOIL to do that. X squared times x is x cubed. X squared times 3, a positive 3 is plus 3x squared. And then I have a negative 2 times x, that's negative 2x. And a negative 2 times positive 3 is a negative 6. And so I'm really finding the integral of x cubed plus 3x squared minus 2x minus 6 with respect to x. That's really all I'm needing to find. It just kind of was hidden from me. And so this is nothing more than the integral of a polynomial, isn't it? So I'm thinking, what's the integral of x cubed? Well, that's going to be add 1 to the exponent. So I now have an exponent of 4, put a factor that's the reciprocal of that. Then I've got my plus 3x squared that I'm taking the integral of. Well, there's my 3. I'm going to increase the exponent on the x by 1. So now it becomes a power of 3. But I've got to put a 1/3 factor, the reciprocal, in front of that, don't I? And then I have a minus, and I've got this 2. And then I've got the x I'm going to increase the exponent on. And then I'm going to put a factor that's the reciprocal of that in front. We actually might have recognized what those integrals were right away, but I've written it out. And then minus the integral of a constant is just that constant times the variable, isn't it? Plus our constant of integration here. I kind of got crammed in there. Let me come down here where there's plenty of room now and rewrite this. That's 1/4 x to the 4th. And then 3 times 1/3 is just 1, so this will be plus x cubed. And then minus, and 2 times 1/2 is just 1, so it's just minus x squared. And minus 6x, and plus our constant of integration. So I didn't take the integral of each part, I multiplied it together, each factor that is, I multiplied it together, and then just took the integral of the entire polynomial. And that's the way we would have to do it. Okay, like I said, one last problem here, one last example, and only because it's a little bit messy, and I'm just wanting you to feel comfortable that you can do it. So find the integral, in this case, of, what do I want? Okay, let's say 8 times the cube root of x minus 6 over the square root of x with respect to x. Okay, well, we've got a little bit of a mess because of all these radicals. But again, the way I'm going to deal with, let me rewrite the problem down here. The integral of 8 times the cube root of x minus 6 times, minus 6 over the square root of x. That's the integral we're supposed to find. I tell you what I'm going to do, and this is normal. I'm going to rewrite these radicals so that I see them as powers. Okay, so really what I have here is 8 times x to the power 1/3, isn't it? Cube root of x is x to the power 1/3 minus, now the square root of x is x to the 1/2 power. So that's really 6 over x to the 1/2 power. Now remember, I can't really deal with denominators when I'm integrating. So before I actually start my integration process, I'm going to rewrite that x to the 1/2 power that's in the denominator. I'm going to write this as a minus 6 times x to the power negative 1/2. Okay, there it will look correct. Now I just have regular old powers of x. So when I begin working on the integral of 8x to the 1/3 power, remember I'm going to have my 8 factor, and then I've got to figure out what power to put on x. And remember, I'm going to increase it by 1. So I've got to take that 1/3 and increase it by 1. Well, that's 1/3 plus 3/3, which is 4/3. So the power on x here is actually 4/3. And remember, then we have to make sure that we have the reciprocal of that power as a factor in front. Okay. Now here's I'm going to take the integral of this 6x to the power negative 1/2. Here's my 6. Now what I've got to do is know what, and I'm going to put a new power on x. And that new power is the old power negative 1/2 plus a 1. Well, that's not going to take us long to figure out that that's a positive 1/2. So my new power is a positive 1/2. Now I have to put in front the reciprocal of that power. Well, the reciprocal of 1/2 is 2, isn't it? 2 over 1, or 2. And so I've got a factor of 2 there. And then plus our constant integration. After all that work, we sometimes forget that. Well, now we go back and we just simplify what we've got. And this 8 times 3/4, well, 8 over 4 is 2, isn't it? So this ends up being a 6x to the power 4/3. Minus, of course, 6 times 2 is 12, so that's 6 times x to the power 1/2, plus our constant of integration. Now, this is going to really be acceptable as an answer, most likely. Let me just, again, remind you that we could write this differently. It would be accurate and nothing wrong with it, maybe a little better, actually, if we rewrote this as 6x times the cube root of x minus 12 times the square root of x. Now, the square root of x is clear. X to the 1/2 is just the square root of x. X to the 4/3 power means the cube root of x to the 4th. And of course, x to the 4th is x cubed times x to the 1st. And the cube root of x cubed is x, and that's how we get that x on the outside. And that x on the inside, we can't take the cube root of it because the power is too low. But you can see where that x times cube root of x came from. But like I said, this is probably fine. Just be aware if you see another answer, you might want to know where that came from. Well, this ends the discussion over the indefinite integral or antiderivatives. Good luck on your homework.